Hello amazing students. Today we're going to be going over the Chapter 8 test review. Part 1 we'll be going over 8A and 8B, and in Part 2 we'll be going over 8C and F7. To prepare, make sure to have a graphing calculator and a writing utensil. Let's begin. So a couple things to point out is when we're using our graphing calculators, make sure to locate the exponent button since we are doing exponentials. So the exponent button will be right here. You also need to find the X button if you're ever going to use the graphing function. So if you're going to be graphing, for example, this equation 125 times 0.2 to the power of x, you'll need to find out where the exponent button is and also the X button. So the X button is right here, so you can actually type this equation. So if I delete it, I can retype it. So again, we press y equals so that we can graph. I'm going to press 125 parentheses 0.2 close parentheses to the power of, so the power of will be this button right here, to the power of x. So x would be this button. Once I do that, I can see the graph of it if it fits on my graph. You'll see it does eventually fit on my graph. And most importantly, I can see the table. So the table allows me to see all the numbers for this function with whole number intervals. So graphing will show me a rough sketch of the graph, but if I press second graph, that'll take me to the table where I can see numbers like this. So for this first one, we're going to go ahead, for this first problem, we're going to go ahead and answer these questions. So it says for number 1, for the equation y equals 7 to the power of x, state the following. Is it growth or decay? Okay, since this number is greater than 1, we know it's going to be growth. I'll just put G for short. Initial or starting value. One way to do this one is going to be to plug in the number 0. So if I do 7 to the 0 power, I will get 1. The second way to do this is to see what number is in front of 7. Since it's y equals a times b to the power of x, a is my initial value or starting value, and there is no number, so if there was a number, it would be a 1 in front. Easier is to plug in the number 0, the starting value. The multiplier is our b value. So our b value is 7, as it's the number in front of the exponent. What is the value of y when x equals 0? Well, we just did that. 7 to the 0 power is 1. And what is the value of y when x equals negative 2? So that means we're going to do 7 to the negative second power. So turning on my calculator, I can do 7 to the negative second power, and it'll tell me the answer. So since this is a decimal, I can go ahead and write down a couple of decimal places. Perhaps 0.02 would be okay. A couple of decimal places is good for accuracy there. Okay. Next up is number 2. Growth or decay. Well, the number in parentheses is less than 1. I always ask myself, would I want to multiply my bank account by this number? I would want to multiply my bank account by 7, but I would not want to multiply my bank account by 1/3. This is decay. It is less than 1. The initial value is going to be 4. It's the number that we have right here, the a value. Alternatively, you can plug in the number 0. So if I do 4 times 1/3 to the 0 power, 1/3 to the 0 power is 1, because anything to the 0 power is 1. And 4 times 1 is just 4. So I know we got the right answer for that one. The multiplier is our b value, which is the one in parentheses, so all I have to say is 1/3. What is the value of y when x equals 2? I'm going to go ahead and use my calculator for this one. So typing in my equation, I can go ahead and type in 4 times 1/3. Remember, to do fractions in your calculator, you can just go ahead and press the division symbol. So 1 divided by 3 is 1/3. And I have to do that to the second power, right? Yes, second power. So if I do that to the second power, I will get a really interesting number, 0.4444444, also known as 0.4 repeating. I think I wrote that down wrong a little bit. Let's say 0.44 with a bar on top, or approximately 0.44. Okay, next one, what is the y value, or what is the value of y when x equals 0? We just did that here earlier. So if we plug in 0 into our equation, 4 times 1/3 to the 0 power, we know that is our starting value of 4. Okay, alternatively, remember, we could have used the y equals button. So y equals, type my equation, to the power of x, and if I press graph, I can see what the graph might look like. But if I press the table, second graph, once it's ready, I will be able to see all my numbers, including my second one, which was 0.444. If I scroll up, I'll be able to see all of the numbers, including 0,4, which we had right there. So that's a great way to confirm my answer. All right, number 3. Number 3 says, what's the initial value of the table? So the initial value is just the 0, the starting value, the y-intercept. I need to find out what this number is. So to do that, I need to figure out what the multiplier is. What's it multiplying by to get to the next number? If you can do this in your head, that's awesome. For example, 4 times 4 is 16. I know that, so I think that the multiplier is probably 4. But to check, what I will do is I will divide. And I will divide backwards. If I do 1.6, I'll divide it by the number that's before it. 1.6 divided by 0.4. That will tell me what number it took to multiply to get to 1.6. 1.6 divided by 0.4. It tells me that the answer is 4. So that was correct. Okay, so I know that the multiplier going this way is 4, and if I go backwards, I will divide by 4. What is 0.4 divided by 4?
It's 0.1.
So if we divide by 4, we'll get the answer of 0.1. That is our starting value. All right, let's move on to a multiple choice question. Remember, every test we're hoping to have a multiple choice question where all we have to do is just circle one answer. So it says to circle the best answer. And let's see what we have here. What I'm going to notice is there's 1, 2, 3 coordinates that are marked with dots. What I'd like to do now is add a 4th dot. This dot right there, that one's called the y-intercept, because that's where it crosses the y-axis, right? Yeah. So now if I locate that one, that is 0,1, and that one is pretty important. All right, so we can look at our options here and see which one has a starting value of 1. Looks like this one doesn't have a starting value of 1, it's -3. This one does have a starting value of 1. This one doesn't, since it's 2. And this one does have a starting value of 1. So our only options are B, D, or E. And we have to figure out the multiplier. So looking at the y values, what would multiply to get 8 to 4? That would be a multiplier of 1/2. What would multiply to get from 4 to 1? Oh, there's something interesting going on here. We're actually missing a coordinate. This goes from -3 to -2 to -1. We're missing that dot. So this one actually does not go from 4 to 1, but from 4 to 2. So that's going to be a half. Okay. And from 1 to 1/2, we know it's 1/2. So the multiplier is 1/2. That means B is our answer. One thing we can do to confirm our answer is to see our graphing calculator. So if you press y equals and type in this equation, 1/2 the power of x, we can see the graph. The graph is not detailed enough to tell if it's the right answer. Okay, it looks good, but it's not detailed enough to see the answer. The table is what shows me if these answers are correct. So if we look at these coordinates, we have -3, 8, -2, 4, the missing one we almost made a mistake on, or I did, 0, 1, and 1, 1/2. So we know this is definitely the right answer. Okay, next, number 5. This is our last question for Standard 8A. Number 5, what is the multiplier of the following table? Well, this should be natural. Look at the biggest numbers on our table, and let's see what multiplier would it be to get to the next number. So to get from 3 to 6, or from 6 to 12, what would I multiply by? Yeah, I'd have to multiply by 2. Now, it's more obvious when I look at the bigger numbers versus the fractions. The fractions tend to be a little bit more difficult to figure out. But if I look at the bigger numbers, it's more obvious. So what is the multiplier for the following table? The multiplier is 2. What's the starting value? Oh, this is kind of easy because it's already figured out for us. The starting value is the y-intercept, which we can go ahead and say is 3, or 0, 3. Okay, next up, what's the equation? So we know that for every exponential equation, we have A is the starting value, or initial value, interchangeable words. B is the multiplier. So even though we did say 2 first, then 3, it does not go 2 times 3 to the power of x. That would be incorrect. We cross that off. This would be 3 is the starting value, 2 is our multiplier, and it's to the power of x. So what I like to do for these types of equations, check this out, is I always read it from left to right. We start at 3 and multiply by 2 repeatedly. Again, I'll say that one more time. We start at 3 and multiply, the parentheses, right, means multiply, by 2 repeatedly. So 3 times 2 to the power of x would be this situation. Again, you could check your work with your tables, and it's always a good idea to check your work, so why don't we go ahead and do that? Go to y equals, clear it, type 3 times 2 to the power of x. Press second graph to see if the table matches up. You'll notice we do have some decimals, so you can go ahead and skip those or understand that these decimals are the same as 3/4. -2, 3/4 is -2, 0.75. A little easier is 1.5, 0, 3, 1, 6, and 2, 12. So this is definitely the right answer. Okay, let's flip over to 8B. 8B. So standard 8B is multiple representations, meaning we have to know some word problems and do a few calculations for these word problems. So our goal is to get a 4 for this one, so we have to be able to do a table, a graph, an equation, and a situation to get a 4 on this standard. So let's begin with number 1. Mr. Chase began investing into a foundation that promised to double his money every year. He cautiously invested only $150 at first and began to see his money double every year. Well, first of all, let me tell you right now, this sounds a little bit risky, right? To double your money is very rare. But he cautiously invested only $150. So let's see what would come of this. Write an exponential equation for the given situation. Okay, that means we need y equals a times b to the power of x. A is our starting value, so how much did he start with? He started with 150. B is our multiplier. So what is the multiplier for the situation? If you're lucky, it's a simple number like 2. Double. And to the power of x would be our equation. Again, it could be to the power of t if we're talking about time, things like that. But to the power of x is just fine. Our next question is pretty quick. How much money will there be in the account after 7 years? Key number, 7. So since we have our equation already, what you could do is create a table like this and figure out the multiplier, multiply by 2 7 times. Otherwise, instead of using multiplication 7 times, we will just do the 7th power. 7th power means we're multiplying by 2 7 times. So I'm going to reset my calculator here and just type this in. 150 times 2 to the 7th power. Press enter and it gives me the answer. The answer is $19,200. That's just by doubling money every 7 years. Okay. All right, number 2. Graph the following exponential function and complete the following table. So what I do like to do for these ones is I like to do these by hand. I start at 4. So 4 needs to be our starting value, which is right here. And I need to multiply by 1.25. So if I multiply by 1.25 repeatedly, I can get all my numbers. So 4 times 1.25 gives me my next number. 5 times 1.25 gives me my next number. That number times 1.25 gives me this number. And just write it down until it fits in my table. That number times 1.25 is going to be this number. This number, let's go ahead and round that to probably a couple decimal places. Let's just say approximately 9.77 to round it. Now we want to make sure to get every single point, so we're going to go backwards from 4. If we're going down, it's multiplied by 1.25. But if we're going up, we're going to divide by 1.25. So, what would we get? 4 divided by 1.25.
The answer is 3.2.
3.2. So my next task for this problem is to graph it. I will go ahead and show you one way to do this a little bit quicker is, remember, we always have the y equals button. If you press y equals, you can go ahead and type this equation. 4 times 1.25 to the power of x. Again, press y equals, type your equation. Press graph. The graph will be such a rough graph, and it goes kind of slowly, you can see as well. That is not enough detail to graph it on paper. So what I'm going to do second-wise is do second table, and I can go ahead and see all these numbers in my table. If I scroll down, I'll be able to match these numbers with the numbers that I got here pretty well as well, pretty nicely. What I want to do now is graph these. So I get negative 1 comma 3.2. We're not looking for perfection. Just graph the dots as close to these values as possible. 0 comma 4. 1 comma 5. 2 comma 6.25. 3 comma 7.8. And 4 comma 9.77. Which is very close to 10. Okay. And then the previous number, if you really wanted to do negative 2, it would be 2.56. 2.56 right there. Let's go ahead and graph a line through it and show that these values are increasing forever. All right, next up, number 3. This is one of our most important problems because it has to do with a word problem that has percentages in them. The most common mistake I see with percentages is we see the number 15 and we expect the number 15 to be in our equation. While the number 15 is only a step to get to our answer. Let's read. Sailor Twift has stopped doing her homework. Uh-oh. And she noticed her test scores have been dropping. They've been decreasing by 15% each test. She got 72 points on her first test. Let's just call this the starting value. What is the exponential equation to model Sailor Twift's expected grade on her tests? If she's consistently dropping 15%, we know that has to be exponential decay. So quick question. Is exponential decay multiplication by 15? No, that doesn't make sense. Is exponential decay multiplying by 0.15? Well, that is definitely decay, but hey, would you want to multiply your bank account or your grade by 0.15? Really think about this question, because multiplying by 0.15 would be a major decrease in your grades. So this one says only multiplying by a decrease of 15%. So know that it's not going to be 0.15. It's going to be something else. So really quickly, on the side of my paper here, I want to show you that you always need to start off with 100%. Your grade always starts off with 100%. Your house value always starts off with 100%. Everything starts off with a 100%. Now you can either go up from 100% or you can go down from 100%. If this says we're decreasing by 15%, then we know we're going to be subtracting from 100. If we're adding 15%, increasing, we know that would be adding 15%. But in this situation, we know we have to subtract since it says decrease. Really carefully, what is 100 minus 15? 100 minus 15 is 85%. And 85% as a decimal is 0.85. Again, you can figure this out by doing 85 divided by 100. That's your multiplier. If you divide by 100, or you can move the decimal over 2 places to get our multiplier. So this question says, write the exponential equation. What's the starting value? Starting value is 72. What's our multiplier? A 15% decrease means your multiplier is 0.85. Now, think about your bank account. Would you be okay with multiplying your bank account by 0.85? No. But it is not a super substantial decrease like it was if we had this one. 15% decrease is 85%. And that's to the power of x. Next question. Approximately how many points will she score on her third test? So there might have been a mistake here. If it says first test means, I guess, the previous test. But let's just go ahead and calculate it as if it was her third test. If you said to the second power, that would be potentially 2 tests after the first test. But don't worry about this situation. This situation is a little bit complicated because it does say first test, but we're going to assume that the starting value is 72. Okay, so what would it be if I plug this into my calculator? 72 times 0.85 to the power of 3 would be an approximate score of 44.2, and we're assuming that's percent. Now, if you did say 72 times 0.85 to the second power, that would technically be 2 tests later. Right. 2 tests later would be the third test. So if we change this, what would that be? That would be a score of 52, approximately 52%. Okay, so this is a little bit tricky. Just if it does say first test, you can go ahead and say third power or second power. I'm sure your teachers will not mind if you did either one. But remember, only one is correct. So if we're really talking about technicalities, first test versus third test would be this one right here. Okay, we could check our answers in the back. If there's an answer key here, yes, there's an answer key. This is problem number, right there. See, the answer key does say 52. And that's why this one would technically be the right answer. Okay, next up is our graph. Last question for this part 1 of 2 series is, from this graph, we're going to create a table. Well, that's pretty easy. 0, 6, 1, 9, 2, 13.5. And then we have to figure out the rest of those numbers. We're missing 2 numbers. Actually, we're missing 3 numbers. So what would be the multiplier to get the next number? So for this question, we have to figure out the multiplier. If we divide backwards, we're going to get the multiplier. 9 divided by 6 is 1.5. Nice. We're going to go ahead and get the multiplier of 1.5. We can check it with the next number. Nine times 1.5 is 13.5. 13.5 times 1.5 is 20.25. And 20.25 times 1.25, our multiplier, would give us this decimal, 25.31 approximately. Last number is, if we divide by 1.5 backwards, we'll get the answer. 6 divided by 1.5 is 4. So that would complete the table. That's all it asks us to do, so we're done. That is standard 8B. And we're going to go ahead and move on to part 2. You might need to click on the next video for part 2, which is standard 8C and F7.